Hey geometry students, here we go again. We are going to be dealing with the surface area of pyramids and cones. Let's go ahead and cover the vocab and definitions and our equations, and then we're just going to jump right into one. Okay, hopefully you watched the drawing of figures. If you're already an artist, you probably could skip it. Again, I make no claim of fame of being an artist. I just love shapes and figures and mathematics. But okay, so I'm moving my document camera here. Okay, so pyramid, you can read the definition of pyramid. Okay, what I want to focus on, you've got this lateral edge, you've got this slant height. This is probably the hardest part here, because this edge here on the triangle, the vertex edge here, that's not going to help us in our equations. Okay, so if we're ever given that, then we most likely have to use a Pythagorean theorem here to get that. So height, it's kind of hard to see, but height of the pyramid is going to be from the middle all the way up to the vertex. Okay, we don't need to worry about this height yet. That's going to help us with volume, so we don't have to worry about this height. But for surface area, we definitely need to worry about this slant height, which is on the actual face. So if you were on the Pyramid of Giza here, you'd be walking up the outside edge of this, or using some ropes and stuff to go up this if this was a smooth surface, and they'd probably get in trouble because you'd probably get thrown in jail or something, because you're not really allowed to do that. So this is slant height. It's perpendicular again to the outside edge here, the bottom of the base. Okay, so it's perpendicular, so it has to be perpendicular, and it's on the actual face. Okay, so slant height is different than height. Okay, it will be at an angle going towards the vertex, and it is not this outside edge here. Not. Okay, that's critical. All right, so that leads us to our equation. Here's a good picture of a net, if you will, of a hexagonal regular pyramid. Okay, so hexagonal base, and then all these, if you were to fold these like a piece of paper and fold all these up to that point at the middle, and you can see that slant height is this one here of the triangle. So you can take the side and break it off into an individual triangle. Okay, that's slant height. The equation, okay, it's given over here. Surface area, again, I used SA. Surface area of a regular pyramid, okay, is area of the base. Okay, so no matter what the base is, you have to first find the area of the base. Well, you could do this first, but because addition is commutative. Then it says 1/2 P times L. P is perimeter. Okay, and this only works if it's a regular polygon. Perimeter is going to be the number of the sides multiplied by the side length. Number of sides multiplied by the side length, and then slant height, which I already covered. Okay, we're going to deal with a cone next. Okay, cone formula is almost exactly the same thing. It's area of the base plus 1/2 multiplied by the perimeter times the length. Well, on a circle, you don't really have a perimeter. It's called the circumference. And circumference is 2 pi r. So the formulas are actually very similar. The only difference is we're dealing with a circle base, and we're dealing with a polygon, or different, square, rectangle, etc. base. Okay, so pi r squared plus this. Let's take a quick look at the net of a cone. So if you're looking at the cone here, all right, again, height in red, we don't need to worry about that yet. That's going to be for help us with volume. But the slant height, okay, slant height's different than on a pyramid, because slant height is going to be the same throughout the whole thing, because it's a cone, and it's the same, it's going all the way around. So that cone, that is the slant height the whole time. So looking at a net of this, it's going to be the area of the base plus this blue area, so slant height multiplied by 2 pi r circumference. Okay, so if you were to cut this out and fold this up and put this together, you could create a cone. Okay, all right, let me pause and get started on the first problem. Okay, so we want surface area. This is this is an example. So we want a surface area of this octagonal pyramid. Okay, it's got an octagon base. Okay, and I could draw the backside in dashed if I wanted to. And this is the base, kind of blowing, separating it. Now, if you remember, so the latter part of this is easy. This is 1/2 PL. Well, since I've got side length, I'm given slant height, so all I have for this part, this is called the lateral surface area. So if you're ever asked for the lateral surface area, this is the lateral surface area. This is the area of the base. So if you're ever asked for the lateral surface area on both of these, it's this. Okay? So I'm going to just go over the area of the base again. Well, not real fast because we've already spent a lot of time on this. So this is the octagon. I'm going to take an octagon, divide it into the central angle. I need to find that central angle. 360 divided by 8 is 45. I'm going to take this triangle here and focus on that triangle here. Okay, so central angle is 45 for hold this, but I'm going to take this, divide it in half. That's going to make this congruent to that. So half of 13 is 6.5. Half of the 45 degrees is 22.5. I'm going to set up a trig function here. So opposite this is going to be 6.5, adjacent A. So that's going to be tangent 25.5 equals opposite over adjacent. Okay, solving that, the apothem, okay, A for apothem, is 15.7. Okay, so boom. Okay, so we got it all. So we got 15.7. So remember, surface area is area of the base plus the lateral surface area. So I like to use 1/2 ANS. Okay, so 1/2 times apothem times the number of sides multiplied by the side length, which is 13. Then we've got 1/2 times number of sides multiplied by the side length multiplied by the slant height. Add those two sums together, we get 1,752.4 feet squared. Again, I dropped the units within the work here, but don't forget the units at the end. Okay, if you want to carry the units without it or within, that's fine. When you get to physics, I highly recommend always keeping your units. Units will help you determine like what is the answer supposed to be. So, what is the answer supposed to be? So, anyways, all right, let me continue. Alright, this next one asks us to find the lateral surface area of like something like a grain silo, although it's centimeters, so I can't imagine that's going to be a grain silo. Alright, so this is where we have to go, or not the lateral surface area, the total surface area. Okay, this is where we have to go, okay, what do we need? What are all the surface areas that we have? Okay, so imagine if we can knock this down. So if we could tip this over, we're going to have a base on the bottom down here. Okay, so we're going to have a base of the cylinder. So I'm going to just say base cylinder here. Okay, so base of the cylinder. All right, plus, okay, there's all this thing wrapped around the edge of this. So just one base, though, one base. That's critical, not 2B like we did the other day. This is just one base. Hopefully you can see there is no second base. It's covered up by this. There's no second base in there. It's covered up by the cone on the top. So only one base down here at the bottom plus the lateral surface area of cylinder. Okay, this is the work. This is the rest is just plugging in numbers. Okay, the lateral surface area and then the lateral surface area of the cone. Okay, this is the magic line here that I love to see. So when you're doing your work, I want to see this. This is going to be the base of the cylinder plus this, the lateral surface area of the cylinder, plus this. Then I just put in the equations. Okay, I wanted to come back real quick because I made a big oops here. It's 1/2 times circumference. And notice what I have here, 1/2 times 2 pi r L. Oopsie, I forgot to carry my 1/2. So in the book you have the correct one. But let me squeeze in 1/2. You know how you guys do it, squeeze on the little edge there. So this formula is going to be pi r squared plus pi r L. And so that's in the book. So the 1/2 and the 2 cancel out. So, okay, so now I'm reflecting that down below. 1/2 times 2 pi r L, which is just pi r L. Okay, so now I'm going to put the corresponding parts. So this radius here is the same as this radius here. They are congruent. Okay, this is my height. Okay, oh, but they gave me this height of this cone. I don't have L. Let me fill in what I got and figure out what I need. Okay, so filling in what I need. I still don't have L. I don't have the slant height here. Uh-oh. Wait a second. I bet there's a way I could figure out what this is. I imagine if this was 4, this is 5. Oh, the Pythagorean. Oh, yeah, or Pythagorean, depends how you say it. Pythagorean theorem. This would be, so let's do that off to the side. So, geometry teachers don't always like to give all the information. They expect you to be able to determine the information. So, with the given information, the slant height's not given, but that's all right. This height's given. This is given. So, using 4 squared plus 5 squared equals slant height squared. Okay, it's approximately 6.4. I'm going to substitute that in for here. Now, as you guys get older, especially in upper level mathematics, you probably could leave this in terms of pi and put this down here, or go from here to your final answer. For me, I still want to see these in case you make a calc error. You guys are still young in your mathematics, that I still want to see this, and it helps me see your work. It also helps me see if you make a mistake. I can, take off a half point because you forgot you did an oops or something. But, work is the answer. As you get older, obviously, in your upper mathematics, you're going to be able to show less work because you're going to be showing more of a different type of work, especially in calculus. You'll be doing integrals of long equations and stuff like that. So there is always work to be shown, and as you get older, you get to have better shortcuts and stuff. But for me, for right now, I want to see this work. This is what work looks like, and this is what I want to see if you want to receive full credit. If you go from here to there, you're going to get a big fat 0. Okay, so I don't mean to be so stern, but that is part of math, showing me that you understand what you are doing. Okay, and if you need to do work off the side like this, then show that. And you don't need to rewrite this whole line. Just do a little arrow and say, I'm plugging this value in for that. Okay, so we've covered a pyramid. We've covered a cone with a cylinder. Okay, the only thing we did not do the base of that cone, although this base of this cone would be the same as that base right there. Consider they would be congruent. All right. All right. Let's see if we can do time for one more. All right. This last one is what if we're working backwards? Okay. So I'm going to say, what if we are given the surface area of a regular pyramid? Okay. So this is going to be an equilateral triangle, and we're given the surface area. We're given one of the side lengths, and we want to find L. Okay, I want to find L. I'll draw that in a second. Okay, so in order to do that, we've got to work backwards. All right, if you're really math savvy here, you could solve this. Here's the equation, and solving for L. Take surface area minus B, divide by P, multiply everything by 2. You're ready for physics. I mean, boom, algebra 2 is going to be a breeze. Okay, but if not, no big deal. Okay, so I'm going to take this right here. This is 1 dimension, or 2 dimensions here, not 3. This is the base. This is that base right here. Instead of using the central angle, I just use the fact that it's an equilateral triangle. Okay, and so the fact that it's equilateral triangle, that's 5, 5, and 5, and then I'm just going to cut it in half, make it perpendicular, because I can do that with an equilateral triangle. This is going to be congruent to that. Okay, let me draw that. Congruent to that. So that's going to be half the 5, so that's 2.5. So then I need the height of this triangle, because I'm going to find area of the base using 1/2 base times height. Okay, so that's going to give me the area of this base here. Okay, so I'm just plugging everything in. So surface area is 75 inches squared. I found the area of the base. Okay, area is 1/2 base times height. Okay, I forgot to have a square root here, so this is what I'm looking for, the height. This is the hypotenuse. This is the edge. So 5 squared minus this, square root of that. So base, height, I get 10.83 inches squared. Boom, boom. Now we're just looking for L. I'm going to subtract this value to the other side. Then I can multiply both sides by 2. Then I can divide by 15. Okay, so again, I like to do it all at one time with this, solving algebraically. But, showing work here, boom, boom. Again, I don't want to speak out of both tongues here. This is showing work. So if you've done this and then plug in the numbers, I'm fine with this. This is showing me you solve for L. Okay, but if you need to do it in steps, totally fine. Okay, you always have to show the setup and then show your algebra in between. So final answer is this. That's the slant height. That's what we were looking for over here, and then we're done. May the good Lord bless and keep you. I'm out of time.